Alrighty, last video for this set, we're going to talk about gas forming reactions. This is a subset of acid-base reactions. This isn't found in the text, but I also think it's very important for us to know some of these as we go. Okay, again, we have to know what the patterns are so we can predict the products of what's happening going on in here. And I want to make sure that we all realize that we're talking about a gas is forming. So we should see bubbles as we do this. Okay. All right, there are two ways for this to happen. One way is through a direct reaction. The only one we're going to talk about in terms of a direct reaction is taking whatever acid we want, reacting with anything that has a sulfide in it, and this will produce H2S gas. And we can predict this using the metathesis. Okay, so let's see what we got here. If we take sulfuric acid, H2SO4, and react it with lithium sulfide. I'm doing this aqueous, although it doesn't have to be aqueous. Okay, we're looking at this. Say we're taxed with this. We're predicting the products. Look for the patterns. Okay, we've got acid and I just messed something up. We got acid and we have something with sulfide in it. So one of our products then is going to be H2S gas. The other product is the salt that's the crap that's left over. So what do we have? We have lithium and we have sulfide. So that's lithium. We can write that out. Lithium plus SO4 2 minus. And since we have one lithium plus and we have SO4 2 minus, this is Li2SO4, and this will be aqueous. Okay. We want to make sure it's balanced. I believe this guy is balanced the way I wrote it. 2 lithium, H2, H2SS, sulfate, sulfate. Okay, we're good. All right. From this, we can write the net ionic equation. And this is going to be the same idea as we've always done. Take your strong electrolytes and break them down into ions if they are aqueous. So sulfuric acid, strong electrolyte, strong acid. So this is 2H plus aqueous plus a sulfate aqueous. Li2S is an ionic compound that's aqueous, so we have 2 lithium plus that's aqueous and a sulfide that is aqueous. Next to that, then we have H2S, which is a gas, so it's going to stay together because it's not aqueous. Okay, and then we have lithium sulfate, which is aqueous, which is an ionic compound that's aqueous, so we have 2 lithium plus and a sulfate 2 minus that is aqueous. All right. Now we should all know by now that we got to cross out our spectators. Look what we got. We have sulfate over here and sulfate over here. We have 2 lithium and 2 lithium, and that leaves us with a net that is 2H plus aqueous, S2 minus aqueous, and oops, not plus, arrow, H2S gas. Not too bad. Make sure it's balanced. It is. There's our net ionic equation for this dude. This is the only direct reaction we're going to worry about. Okay. There are probably others. We're not going to stress about it. This is what we're going to do. H2S gas. All right. The other kind we're going to look at, there's 2 examples of this, and these guys go by making an intermediate product. So what happens is our 2 things react together with each other, acid and something else, and they make a product that instantly decomposes into 2 other things. Okay, so we're going to get a lot of stuff when we do this. Let's look at this then. Look at this example. We're going to take HCl, aqueous, and we're going to react it with sodium bicarbonate, baking soda, NaHCO3. All right, the pattern we're looking at, not gas, what am I talking about? This is aqueous. The pattern we're looking at here is carbonates and bicarbonates, and carbonates and bicarbonates with acid produce CO2. Okay. So we should do that. Now, I'm going to give you a note here. I'm trying to figure out what the best way to explain this is going to be. If you predict this with a metathesis, what you're going to get is you're going to get H2CO3, which is aqueous, and you're going to get NaCl, which is aqueous. This is our intermediate, the carbonic acid intermediate. This thing is unstable and decompose. What happened? Okay, I don't know where there it is. Okay, this thing is unstable and decomposes to give us two other products. So this thing is our intermediate. Okay, and it's going to decompose and give us water, liquid, and CO2 gas. Okay, this is the gas that's given off, and this is where it comes from. Okay, so when we have carbonic acid, when we have carbonates or bicarbonates, we're going to get CO2. Ultimately, you don't have to show me this. Okay, you need to show me what the final stuff is. So ultimately, our answer should be HCl aqueous plus NaHCO3 aqueous gives us water, liquid, CO2 gas, and NaCl aqueous. Okay. If we want to write our net ionic equation for this, we can write our complete. HCl is strong, so this is going to be H plus. I'm going to have to write kind of small to get this all in here. Aqueous, Cl minus, aqueous. Sodium bicarbonate is a sodium aqueous, and a bicarbonate, HCO3 minus, aqueous. Okay. Water is a liquid, so it does not come apart. CO2 is a gas, so it does not come apart. NaCl is ionic, so this is and it's aqueous, so we can say sodium plus and Cl minus aqueous. Okay. Now look for your spectators. There's a chloride over here and a chloride over there. There's a sodium here and a sodium there. And then we've got our net that says H plus aqueous plus HCO3 minus aqueous will give us water, liquid, and CO2 gas. Okay. It's a little bit more intense than we're used to, but it works. It follows the same guidelines. You just need to know what our ions are and how to figure this out. Okay. Let's look at the other one. If we have sulfites and bisulfites, we're going to get SO2 gas. Okay? This works the same way the other one did. We could literally take this equations, all of the work on this slide, replace all the carbons with sulfurs, and everything is exactly the same. Okay, but let's look at a different example so we can see it. Okay, let's take HBr, aqueous, and we're going to react it with K2SO3 aqueous. This is going to give us intermediately. Remember, you can use your metathesis and predict this to be, we're going to get H2SO3 aqueous sulfurous acid, and we're going to have KBr, that's the salt of the crap that's left over. This is our intermediate, which I probably should have marked in a different color. This is our intermediate. The sulfurous acid decomposes rapidly and gives us water and SO2 gas. Okay, now we can write the full equation. This is our final answer, HBr. Well, maybe not our final answer, but this is our final reaction. Plus potassium sulfite, SO3 aqueous, gives us water, liquid, SO2 gas, and KBr aqueous. Okay. We want to make sure this dude gets balanced. We need 2 potassiums, so we need 2 of those. That gives us 2 Brs, so we need 2 of those. That gives us 2 H's, and we have H2O, so that's good. Okay. Let's dissociate this and come up with our net ionic equation. HBr is a strong acid, so we're going to dissociate this guy. 2H plus aqueous plus 2Br minus aqueous plus potassium sulfite is a strong electrolyte, so we're going to dissociate it. 2K plus aqueous plus SO3 2 minus aqueous gives us water is a liquid, so it stays together. SO2 is a gas, so it stays together. Then we have 2K plus aqueous and 2Br minus aqueous. Again, find your spectators. What do we got? 2Br minus and 2Br minus, 2K plus and 2K plus. Everything else is fine. Let's write this out as our net. Our net is 2H plus aqueous and a sulfite, SO3 2 minus. Yes. Oops, I forgot my aqueous. And we get a water, liquid, and SO2 gas. And that's our net ionic equation. Okay. It's the same idea as with carbonate. You're just going to replace the carbons with sulfurs and you get the same thing. Okay. Last thing I want to tell us is this is a summary. Okay. We need to know what the patterns are. Okay. You don't have to tell me what the intermediate product is. Okay. You do have to know what the gas evolved is. These two also give you water. Let me get these circles out of here. Okay. I also want you to watch out for solid reactants. So here in this video, they're putting HCl on solid calcium carbonate. You can see the bubbles of CO2 coming off, but our carbonate here is a solid. So when we write the net ionic equation for that, it's going to stay together as a solid, even though we may or may not predict that to be solid or whatever. Okay. If you need anything, let me know. I'm here. Ask questions, and I'll catch you in class.